So today we're going to be talking about complex numbers. Um, to start with, does anyone know what a complex number is?
No.
Okay, well, a complex number, also sometimes called an imaginary number. Does anyone know what an imaginary number is?
One that's pretend?
Good, yes, actually that's exactly true. Let's dive a little deeper into what you mean by pretend.
I don't know.
Okay, well, complex and imaginary are kind of like the same thing. A complex number and an imaginary number both contain I. Okay, do you know what I equals?
No.
It's equal to the square root of -1, which, as you remember, the square root of -1 does not exist because you cannot take the square root of a negative number. Okay, so an imaginary number is I, any number that has an I attached to it. For example, 3i is imaginary. Okay, now a complex number goes a little bit more in depth into that. A complex number has both a real part and an imaginary part. Okay, so for example, and a complex number would be 4 plus 2i. That would be a complex number. Okay, another example would be 6 minus 4i. Those are all complex numbers. Okay, now, does anyone know why we consider all real numbers complex numbers as well?
No.
Remember a real number, you can write it as like the square root of 2 or 4 or e or pi or any of those. Okay, a complex number can be written, or a real number can be written in terms of complex, because all you have to do is go like this. The square root of 2 plus 0i. That's a complex number. It's just that 0 times anything is going to be 0. So, complex numbers, or real numbers, are complex numbers. So, you can add and subtract complex numbers. Anyone know what this might look like?
No.
Well, the sum, also addition, we're going to use a plus bi plus c plus di. Okay, where a, b, c, and d are all real numbers. So they're actual numbers, we just don't know what they are. Okay, but we know they're numbers. Okay, so to add the sum of complex numbers, or to add complex numbers together, all you have to do is add the two real parts. Okay, and remember, the real parts are the parts without i's attached. So it would be a plus c. And to find the imaginary part, all you have to do is add the imaginary parts. B plus d, and attach an I. Okay, difference or subtraction looks very similar. Okay, subtraction would be a plus bi minus c plus di. Okay, it's very similar to addition, just a little bit different. Instead of going a plus c, you have to go a minus c plus b minus d I. So let's do an example of that. So let's say I gave you 4 plus 2i plus 3 minus 6i. Okay, so knowing what I just did, what do you think you should do first?
Add the 4 and the 3.
Good, exactly correct. So we're going to add the 4 and the 3. And what's 4 plus 3?
7.
There you go. Good. Okay, now what's the next part we should do?
add B plus D, so
Mhm.
2 plus 6.
Exactly. This one's a little bit different though because
There's a negative.
the negative sign goes along with the 6, so it's 2 minus 6.
Okay.
Okay, up here where we did the addition part, okay, whatever sign is there, see how this was a plus sign? It just goes along for the ride.
Okay.
If this were instead of minus, it would be a minus there instead.
Gotcha.
Okay, so what's 2 minus 6?
Negative 4.
Good. I. Now, we rewrite that so that it's like that. And there's your answer. Okay. Why don't we do a subtraction one really quickly? So let's say I gave you 2 minus I minus 8 plus 3I. Okay, what's the first thing you do?
2 minus 8.
Very good. 2 minus 8. So 2 minus 8. And what's 2 minus 8?
Negative 6.
Okay. Now, with the minus sign, it's a little bit weird. Okay. The minus sign, usually you would just go 2 minus 8. Okay. Which is exactly what you do. But you got to figure out what goes in the middle here now. Okay. We're going to leave that blank for a second. Okay. So, what would you do next?
I minus 3I, or, yeah, but there's a plus sign.
Yeah, so negative I plus 3I.
Oh,
But
gotcha.
this is where it gets a little weird because that negative sign screws things up. Okay? Usually when you're doing subtract or addition, you carry along this sign, whatever it is. But when it comes to subtraction, this sign changes to the opposite. So instead of being plus 3I, it's minus 3I. So what's negative I minus 3I?
Negative 4I.
Good. Okay. Whatever you get when you subtract or add or whatnot here is the sign that goes along. So your final answer would be negative 6 minus 4I. And there's your answer. Okay. So questions about adding and subtracting complex numbers?
None.
Okay. Now we're going to do how to multiply complex numbers, which is it's a little bit more challenging, but still very easy. Complex numbers. So before we get into how to do that, I have to teach you what the pattern for I is. So what does I equal?
An imaginary number?
Or the square root of negative 1.
Oh, yeah.
Okay. Now, I squared is just equal to negative 1. I to the third is either equal to negative I or negative square root of negative 1. And I to the fourth is equal to just 1. There's a reason I'm teaching this. It's not because I just enjoy seeing you guys do this. There's a reason why. Okay? Now, if you go I to the fifth, guess what it equals?
I have no idea.
Square root of negative 1. What do you think I to the sixth equals?
Negative 1?
I to the seventh?
Negative I.
Or
Negative square root of negative 1.
and I to the eighth?
1.
Good. What do you think I to the ninth is?
Square root of negative 1?
Yeah.
Oh,
The pattern continues.
Oh, good.
Okay, I goes in a pattern like that. Okay, and that's important because in the next section we learn how to figure out what like I to the 576th power is. Okay, so we'll learn how to do this in the next section, not right now. But I need you guys to know at least the first three, because when you multiply complex numbers, those come back to haunt you. Okay, so let's move into multiplying complex numbers. So A plus BI, C plus DI. Remember, we're letting A, B, C, and D be what type of numbers?
Real.
Good, real numbers. We don't know what they are, but we know they're numbers. Okay? So, to multiply complex numbers, all you do is you use the something called the FOIL method, first, outer, inner, last. Okay? So, you would go A times C plus A times DI plus C times BI plus BI times DI. Okay, now the easiest way to show this is to really do an example. So let's do an example of 2 plus 3i times 5 minus I. Okay, so again, we're going to use FOIL. And remember, FOIL is first, outer, inner, last. Okay, what would the first thing you do be?
2 times 5.
Good. So 2 times 5 plus what?
2 times I.
Okay, 2 times...
Negative I.
Good. Negative I. The sign, whatever sign is in front goes along for the ride. Okay. Plus what?
5 times 3i.
5 times 3i. Or 3i times 5, doesn't matter. Plus, what's the last thing?
3i times negative I.
Good. Okay. 2 times 5 is 10. Plus 2 times negative I would be just negative 2i. 5 times 3i is 15i. Plus 3i times negative I. That is negative 3i squared. Okay, this is why I went over that pattern with you earlier. It's because you start getting I squared. Okay, so 10 plus, what's negative 2i plus 15i?
13i.
Okay, what does I squared equal?
Negative 1.
So it would be plus negative 3 times negative 1, which would then be 10 plus 13i plus 3. 10 plus 3 is 13 plus 13i. And it is purely coincidental that both the numbers here are 13. That usually does not happen.